Hello and welcome to this NEP for Arithmetic series. So that's notes, examples and practice questions, and this is directly leading on from arithmetic sequences. So that's your title, so get your folder or your notebook or wherever you're keeping track of these notes. Your title is Arithmetic series, and we're going to go straight on to the notes section. So firstly, the definition of an arithmetic series. This is the sum of the terms of an arithmetic sequence. So that means we take the terms and we add them up. So 1, 3, 5, 7, 9 is a sequence, but 1 plus 3 plus 5 plus 7 plus 9 is a series. So crucially with a series, what we're doing is we are adding these up here. Now we have a formula for this as well. This is given to you in your formula booklet, so you do not need to learn this. The formula for the nth term, remember that is the general formula, is Sn equals, so S for sum, n over 2, 2a plus n minus 1d. Now, you can also use this formula, Sn equals n over 2, a plus l, where l is the last term. And again, that is given to you as well. So I'm just going to put a little red star by both of these. They are given. So you might want to write that down as well. They are given to you. And we're going to see how you use them in the examples. Now you might, in the blue box today, you might be asked to prove the formula for the sum of an arithmetic series. If you'd like some help with that, then do get in touch. You can find an example of that in the textbook, or I'm sure there are videos online that do that as well. I'm not going to go through it here, but if you would like some help with that, then do just get in touch. Okay, so moving on to the examples. These are examples for arithmetic series. So we want to write this down nice and clearly. Number 1, find the sum of the first 20 terms of a sequence with nth term this. Now remember, what we're going to do is we're going to start with our box. So A equals D equals N equals, but this time we need the sum. Now N equals 20, and I need to work out the first term and the common difference. So what I'm going to do is I'm just going to generate the first few terms. So if N equals 1 for the first term, if N equals 2 for the second term, and if N equals 3 for the third term. The first two is enough, but that just helps us to check. So you can see here that's our sequence. So A is 78 here. It's going up in 3s, so D is 3, and N is 20. I'm trying to find the sum, so that is what I'm looking for. And if the rest of my box is full, I can proceed straight away, starting with my formula. So Sn equals, this is my formula. And all I'm going to do is I'm going to sub in the information I have. So N is 20, A is 78, N is 20, and D is 3. And then I can put, and this is actually the sum to 20, I can put that all in my calculator. So literally just copy that exactly as it looks. I try and avoid taking shortcuts if I were you, just in case you muck it up. So the sum of the first 20 terms is this, and that is your answer. Okay, question number 2. Find the sum of this series. So that series goes up like that. Now we're going to start with a box. So A is 7, D is 5, N I don't know, and Sn is what I'm trying to find. I'm trying to find the sum. So what that means is the first thing I actually need to do is I need to find the number of terms. And I'm going to have to find that for both formulas that I can use. I've got the last term here, so I could use my second formula, which we'll come to in a moment, but we still need to find the number of terms. Now, what this means is trying to work out what n is for that final term. So remember, our regular nth term formula for the sequence, un equals a plus n minus 1d. Now I'm trying to find out what n is for 107, so a plus, I don't know n, d. And I can solve this. So the very first thing I'm doing is I'm going back to my knowledge of sequences and solving, so n equals 21. Because now what I can do is I can find my sum. Now we have two options. The first one, so sum of the first 21 terms, too many brackets there. So S21 equals 1197. If you wanted, you could use the alternative formula, which is S21 equals n over 2 a plus l. So that's n over 2 a plus l, where l is the last term, and that you will find is the same. But in both cases, you need that n here, so that's what you have to find first, and the box helps you identify what you need. Okay, question 3. How many terms are required for Sn equals this to exceed 1,000? Okay, so again we're going to start with our box. A equals, D equals, not sure on those yet. How many terms are required? So n is what we're looking for. And actually we know what the sum is, so Sn is 1,000. Okay, now what we're going to do is we're just going to generate the first few terms to work out A and D. So minus 2 plus 3, that's a 1, is 1. S2 is 4, and S3 is 7. So my first term is 1, the difference is plus 3. And now all I'm trying to find is n. So how many terms are required for it to exceed, and we'll come back to that in a moment, 1,000. So we've got our sum formula. And then I'm subbing into that. I don't know n. And I'm going to find when n equals 1,000. So I am now simplifying this. The first thing I'm actually going to do is I'm going to times by 2 on the outside. And I'm going to expand all of this in here. So I have n, 2 plus 3n minus 3 equals 2,000. Just gets that half out of the way. Then simplifying inside the bracket. And then I'm expanding. Now what I've got here is a quadratic, so to solve that I need it to be equal to 0. And I'm going to solve that on my calculator. So menu A, 2, and the degree is 2. Putting those values in, and I get n equals 25.98 something, or equals minus. Now that is not possible, because we can't have a negative number of terms. So if n equals this, then the first term to exceed, n equals 26. And I'm just going to check that by putting in 26 in here and in here. In fact, in here and in here. So 26 over 2, 2, 1 plus 26 minus 1 times 3 is 1,001. So that is correct. Okay, so we want to look at a summary now. So you might need to use un equals a plus n minus 1d, and your knowledge of sequences to find a, d, or n, and you want to always show your information in a box, as it helps to see what is needed to answer your question. Okay, so put a little red box around that, make it really clear that is the end of your notes and examples, and then we're going to go on to the practice questions. Okay, here we have the practice questions. I propose you do these somewhere separate to your notes and your examples. You want to keep them nice and neat and nice and safe on their own. So practice questions on some paper or in a different notebook maybe. And we're going to start with question 1. Find the sum of the first 50 even numbers. Okay, so I'm going to start with the box. Now the first even number is 2, and even numbers go up in 2s. First 50 and the sum we don't know. So S50, and then we're subbing into this formula. Is 2550. Now if you wanted, you could use the alternative formula, so n over 2 a plus l, and the 50th even number is 100, which gives you the same answer. Okay, part B, question B, secure. The first 3 terms of an arithmetic sequence are a, 5a minus 8, and 3a plus 8. Prove the sum of the first 3 terms, the first n terms, sorry, is a perfect square. So in my box, a, d, n, well, n is going to equal to n, and the sum is what we're going to be looking for. So remember in our summary we wrote that you have to use your knowledge of sequences to find maybe a or d. This is what we need to do here. So this minus this equals this minus this. So simplifying this, so a equals 4, and I'm just going to sub that into check. So a is 4, 5 lots of 4 minus 8 is 12, and 3 lots of 4 plus 8 is 20. So a is 4 and d is going up in 8s. So now prove the sum of the first n terms is a perfect square. So the sum formula, now it's n over 2, 2a plus n minus 1d. And I'm just going to simplify what I can. Okay, so they're going to cancel. Now that's going to cancel to 4, so that's actually 4n squared. Now, for that to be a perfect square, it has to be something that is all squared, and that's actually 2n all squared. Therefore, it is a perfect square. So that's what that question's asking. Question C, the 4th term of an arithmetic sequence is 4, The sum of the first 8 terms is 60. Find A and D. Okay, so thinking back to arithmetic sequences, remember we have a little mini formula for every term. So the fourth term, U4, is A plus 3D. And that equals 4. And what this question is going to create is it's going to create a simultaneous equation. Now that's one of them, but then I know the sum of the first 8 terms. So I'm going to do a box for this one. So A we don't know, D we don't know, N is 8, and the sum to 8 is 60. So using this formula, so 60 equals 8 over 2, 2A plus, and then I can again start to simplify where I can. So 60 equals 4, 2A plus 8D minus D, which is 7D. Should have simplified my bracket first. I'm actually going to divide by 4, so 15 equals 2A plus 7D. And now we have a second simultaneous equation. Now we can actually solve them in my calc. So A plus 3D equals 4, and 2A plus 7D equals 15. The difficult bit was deriving those equations by using the formulas that we know exist. Put that in your calculator. A equals minus 17, D equals 7. And they are your answers. I'm just going to sub them in here to check. So A minus 17 plus 3 lots of 7 is 4. And then in here as well, so 8 over 2, 2 lots of minus 17, plus 8 minus 1 lots of 7 is 60. So they are correct. So they are the practice questions for arithmetic series. It depends a huge amount on your knowledge of sequences. So if you want to go back and just consolidate those or practice those, there's an NEP for those. Or if you'd like some extra help, please do get in touch.